Okay, hello everyone. In a new video, so we have reached part 6 of chapter 3, which is the chapter of velocity for grade 8 students. In this part we are going to solve some exercises. So exercise number 16, page 67. A car is driven at a constant speed of 5 meters per second on a rectilinear and horizontal road. The travel distance d traveled uh, during time t, so this is t, is expressed with respect to time according to d is equal to 5 times t. In 16.1, they are telling me what's the nature of the car's motion, justify. So this part is not very important, but notice that here the title is, they are telling me that study of a uniform rectilinear motion. So the nature of motion is uniform rectilinear motion. Now let's ignore the justification. Now in 16.2, they are telling me complete the value of d in the table below corresponding to the given instance. So we are supposed to copy the table. Let's copy the table. So here we have time in seconds. So here we have 0, 1, 2, 3, 5, 6, 7, 8. So as you can notice that the value 4 is missing. So this is 0 and d is expressed in meters. Then we are supposed to fill this table using the following relation: d is equal to 5t. So whenever we know the value of t, we can determine the value of d. Then for t is equal to 1, we have that d is equal to 5 multiplied by t, which is equal to 5 multiplied by 1, which is equal to 5 meters. So d is equal to 5 when t is given by 2, this is equal to 10 meters. So here we can say that this is 5, 10. Notice that always in physics all quantities must have a unit, but these don't carry any unit because the unit is already placed in the first column. Now 5 times 3 is equal to 15 meters, corresponding for t is equal to 3 seconds. Now d is equal to 5 multiplied by 5, which is equal to 25 meters. d is equal to 5 times 6, which is equal to 30 meters. And so on. 5 times 7 is equal to 35 meters. And d is equal to 5 times 8, which is equal to 40 meters. Then we can fill up the table. So this is 15, 25, 35, 30, 35, 40. So this is it for 16.2. Now in 16.3, so we are asked to draw on a graph paper the graph that gives the variation of distance d with respect to time t. So first let's represent the axes. Then this is the origin O. So the first step is to label these axes by physical quantities. So notice that here they are telling us the variation of the distance d with respect to time t. So we have two variables and they are given by the distance d and with respect to time t. So the first one that comes after the variation will be represented on the y-axis. So this is d in meters and this is t in seconds. Now let me write the scale here. The scale is given by 1 centimeter corresponding to 1 second on the horizontal axis, and 1 centimeter corresponds to 5 meter on the vertical axis. Horizontal axis and on the vertical axis. So they are telling me on the horizontal axis, the horizontal corresponds for this. For each 1 centimeter, we will add 1 second. So this is 1, 2, 3, 4, and we stop at the value which is given by 8 because it is the largest value included in the table. Then 5, 6, 7, and 8. So independent of the values of the table, we start by 0, okay, and we end by 8, but we move by a step of 1 according to the scale. Now as for the vertical axis, so for each centimeter we are going to add up 5 starting from the origin. So this is 5, 10, 15, and we are going to stop on the largest at the largest value that is included in the table, which is given by 40 corresponding to the distance. So this is 20, 25, 30, 35, and this is 40 here. Okay, so let me extend the y-axis a little bit. So this is d in meters. And now let's label the points that are given in the table. When the time is given by 0, the distance is 0, so this is the first point. When t is given by 1, t is given by 5, so this is 1 and 5. And we complete plotting the plotting the points. So notice that here this is 3. The point 4 is missing, this is 5. This is the 6, 7, and 8 that is here. Okay, so by 8 we have 40, by 7 we have 35, by 6 we have 30, by 5 we have 25, for 3 we have 15, for 2 we have 10, for 1 we have 5. And now we connect these points using a ruler and not by hand. And as usual, whenever we plot a graph, we need to write the title. The title is extracted from the question itself. So this graph or this curve represents the variation of distance d with respect to time t. So this is it for 16.3. Now in 16.4 they are asking me what's the shape of the curve obtained. So this is the curve. Notice that the curve is a straight line passing through the origin. Then the shape is given by straight line passing through the origin. Now in 16.5 they are telling me specify graphically the distance traveled by the car at the instant t is equal to 4 seconds. So what's the benefit of drawing a curve that shows the variation of the s function of t? Is that whenever we know the value of one variable, we can determine the value of the other. Okay, so if you know that the value of time is given by 3, going up to the curve, then moving to the y-axis, we know that its value is given by 15. So the benefit of plotting the curve or the table is that whenever we know the value of one variable, we can determine the other. Now in 16.5 they are telling me specify graphically. So because we are using the graph, we must say graphically. They are telling me specify graphically the distance traveled by the car at the instant t is equal to 4 seconds. So let's say for t is equal to 4 seconds, we need to determine the value of the distance d. We have d is equal to what? Then t is equal to 4 seconds corresponds to this point on the curve. They are telling me construction lines should appear on the graph, so let's do them in blue. So t is equal to 4 seconds correspond to this point on the curve, correspond to this value on the x-axis. So which corresponds to this point on the curve having a value of d is equal to 20 meters. So these are the construction lines, okay? These are the construction lines. So in this case we have d is equal to 20 meters. So the benefit of drawing a curve represented graphically is that whenever we know the value of one variable, we can determine the other. In this case, we have t is equal to 4 seconds. So referring to the curve, we can determine the value of t. And notice that always we are interested in transforming data from a tabular form to a graph, because usually the graph have more information than the table. Notice that in this case the graph doesn't the value 4 doesn't appear in the table, but in this case it appears in the graph. So usually the graph is stronger than the table. Okay, so this is it for exercise number 16. Now as for exercise number 17, a graphic representation of a travel distance. So a cyclist is covering a distance that consists of 3 phases. The graph below represents the travel distance d with respect to time t. So this graph shows the variation of d with respect to time. We have 3 phases, phase 1, phase 2, and phase 3. Let's start by 17.1. They are telling me what distance did the cyclist cover between 0 second and 3 second phase 1. So they are asking me about the distance covered. So notice that the distance represents the y-axis. So during phase 1, the distance is given by 15 minus 0, which is equal to 15 meters, between 0 second and 3 second. And they are telling me to calculate its average speed. We know that the average speed is given by Vm is equal to d divided by delta t. In order to determine the value of Vm, we need to determine the value of d and delta t. Delta t corresponds to t2 minus t1, corresponding between 3 seconds and 0 seconds, which is equal to 3 seconds. So in this case, this is equal to 15 divided by 3, which is equal to 5. Since d and delta t are expressed in the SI, so the value of Vm will be expressed in the SI, which is meters per second. So Vm is equal to 5 meters per second for the first phase. Now in 17.2, they are telling me what happens between 3 seconds and 7 seconds. So between 3 seconds and 7 seconds, notice that the distance d as time evolves from 3 to 7, the distance d is constant, which means that the cyclist is not moving. Now in 17.3, they are telling me what distance did the cyclist cover between 7 seconds and 9 seconds, corresponding to the third phase. So the distance covered in phase 3, so he covered from 15 to 27 meters, so d is equal to 27 minus 15, which is equal to 12 meters. This is the distance covered, and they are telling me to calculate its average speed, which is given by Vm is equal to d divided by delta t, which is equal to 12 divided by. Now we need to determine the duration, which is given by t2 minus t1, which is equal to 9 minus 7, which is equal to 2 seconds, corresponding for the phase 3, 7 seconds and 9 seconds. So this is equal to 6 meters per second. So Vm is equal to 6 meters per second for the third phase. And now in 17.4, they are telling me calculate the average speed of the cyclist over the entire travel distance. Then Vm is equal to d divided by delta t, in which d represents the distance for the whole trip, which is given by 27 minus 0, which is equal to 27 meters. And as for the duration delta t, which is equal to 9 minus 0, which is equal to 9 seconds. So 27 divided by 9, which is equal to 3 meters per second. So the average speed for the whole trip is given by 3 meters per second. So that's it for me in this video, guys. In the next part, we will start a new chapter.